Welcome to lesson 17, solving quadratics visually. Sometimes people may call this solving quadratics graphically. But basically, we're going to use a graph to figure out the solution of a quadratic. So let's get going. We got two learning objectives. First, you're going to find a quadratic solution from a graph. If you remember from last lesson, a graph is called, for a quadratic, is called a parabola. We have one here. The solution is where it crosses the x-axis. It really is that easy. Sometimes the graph may not be given to you, in which case you want to have to plot points from a table to graph a quadratic. And you've done that before with linear. You know, you may have had a table, and you may have had an equation like x plus 2, but 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6. Remember, a quadratic, it's the squaring function. So you would have something like xy. You'd have, let's say, 0, 1, 2, 3. Well, 0 squared, 0. Because nothing times nothing is nothing. 1 squared, well, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So it's really the same concept, but the operations are going to be a little bit different. Just some things you must know, and once again, this is a review. This is a parabola. It represents a quadratic function in graphic form. Your parts of a parabola, well, you got start with your vertex, it's your turning point. And this parabola is a valley, so that has a minimum value. Your x value of the vertex, well, that tells us your axis of symmetry. That's where it cuts it in half and makes it a mirrored image of the other half. Your roots, in this case, you have two roots where they cross the x-axis. Just remember, with roots, with a parabola, you have three options. It could be no roots, one root, or two roots. We're going to work with the range and domain. Once again, your range is your input. It's the number you put into your math problem, and your domain is your output, or it's your answer. You'll have to be able to plot points. So like here, that's 5, 5. You have to be able to plot some points. And then you're going to have to substitute values into an equation. So you may have like x plus, let's make this a little more complicated. You may have like 2x plus 6. You maybe say, so, I may say, what's the value of this function when x is equal to 7? So you do 2 times 7 plus 6. 2 times 7 is 14. 14 plus 6 is 20. You've got to be able to do that. And I know you can do it because we've been substituting values for quite a while now. So here's our quadratic function. This is our standard form of it. You got ax squared plus bx plus c is equal to 0. It's always got to be solved for 0. In this course, it will always be solved for 0. But in more advanced courses, you may have to do some manipulation to make this thing equal to 0. It's the squared function. I've been saying that for a little while. It's a squared function because that's being squared. The x-intercepts is where y is equal to 0. And these are the quadratic solutions. Sometimes we call them the roots. We also call them the zeros because that's where y is equal to zeros. And solution, just to be redundant, the vertex is your turning point. It's either your highest, which would be maximum, or your lowest point, which would be minimum. So your vertex, it's either the bottom of the valley or the peak of the hill. The graph is called the parabola. It's U-shaped. And your domain of the quadratic function is going to be all real numbers. And for this course, we're writing that as ARN, and not all functions will be able to take all real numbers as endpoints. In this class, they will because it's quadratic, but at some point in your mathematical journey, you may have to do what's called limiting the domain. You won't do that today. This is just foreshadow. Some other things, your range is your set of all your possible answers. So like x squared is always going to be positive. Well, let's say if you have like x squared minus 10, well, there could be some negative numbers. There could be some negative answers. Or there could be some positive ones. So like this one, if, x is equal to 2, 2 times 2 is 4, 4 minus 10 is negative 6. So it is possible to get some negative answers with the quadratic function based on the bx or the c. They can pull our positive number down into the negative area. Your axis of symmetry for a quadratic function, it's a vertical line that divides a parabola into two symmetric parts, or two equal parts, or two parts that are just mirrored images of each other. It's a line of reflection for the graph, and to find the vertex, there's this formula. We're not going to actually do that in this course, but if you wanted to play around with it, and I know some people like to play around with it, there's the formula. X is equal to negative b divided by 2a. Here's a review of the parts of the parabola. I'm going to start with the vertex. This one, that's at the bottom of the valley, so it's got a minimum value. Your y-intercepts where it crosses the y-axis. Your x-intercept, which is your root solutions, zeros, they're on your x-axis. So in this case here, it's -1 and -3, or you can write it as negative x0, 3, 0. And your axis of symmetry, which cuts it in half, would be x is equal to -1. So that's our parabola. And let's just look at this equation here. So our domain, it's all real numbers. We can put any number into this. Our y-intercept, well, if you count this is 0, -5. If you come over 1, 2, go down here, where you go, x is equal to -2. So that's our axis of symmetry. Our vertex, well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Our vertex here is -2, 9. And notice the x value of the vertex is our axis of symmetry. Our range, we can't get a number smaller than -9, but we can go on into infinity. This one does have a minimum value. And our zeros, we chose to write them as ordered pairs. You could also use brackets or -5, 1. This is also called a solution set. Solution set. Solution set. So let's look at this. What's your vertex here? Well, first of all, does this have a minimum or maximum value? Well, it's in a valley, so it's got to have a minimum value. Our vertex, well, 0, -5. 1, 2, 3, 4, 5. Here, does this have 1, no, or 2 solutions? Well, this is your x-axis. Probably could have been labeled better. That's your y-axis. Across is twice, so it has 2 solutions. This lesson, we're figuring out the solutions of quadratics by looking at their graphs, or the parabolas. And your solution is just where it crosses the x-axis. I want to put my answer in a solution set called 4, 6. That's it. That's your solution. Some people may want to write it as 4, 0 as a ordered pair, or in 6, 0. That's fine too. I just like the solution set because it's less writing. Here I wrote 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. Here I wrote 1, 2, 3, 4, 5. It's half as much writing. If you wanted, you could see if this has a minimum or maximum value. That's outside the scope of this lesson. But if you're a good math student, when you see something like this, you may want to think about all the other stuff you learned before and apply it here. Solutions graphically. So pause the video, think about this parabola and everything you learned about parabolas, and pause the video and see what you think the solution is. Well, there's no solutions, right? No solutions. N/S, we may say D and E, no roots. A common question, like a multiple choice question, would be, oh, the solution's -4 because that's your y-intercept, but that's not it. That's not a solution. That's just your y-intercept. So on a quiz, be careful. There's no solution because it does not cross the x-axis. Here's another parabola. Now this one's scaled is we don't know what the vertex is. No vertex present. I mean, there is one, and eventually you can take some points off from this, write an equation, and figure it out algebraically. But this throws kids off sometimes. Even though you can't see the vertex, it doesn't matter because our task is to find the solutions, the zeros, or the roots, and I got them circled. So your solution set should have -5, +5. Adjust the scales of your graph so you can see the vertex. There's the vertex. It looks like that's what, 0, maybe -25 for approximating. But your solution, even after you adjust the scale, still -5, 5. So when given a graph and asked the solution of a quadratic, super easy. You just look for the x-axis. If it doesn't cross it, that means it doesn't exist. There's no solution. If it touches it just once, there's one solution. Or in this case, when it touches it twice, there's 2 solutions. Given a quadratic function. And if you're just given a function without a graph, well, you've got to graph it. So this is like graphing linear functions, because we'll use a table. And we'll be given some x values. And whatever x values we get, we just plug into our equation to get our answer or the output. Now just keep in mind, this is a squaring function. So we're going to square whatever number. And then we may need to do some other manipulation. Like it may be a more complicated equation. But it's going to work just the same. So like if we had this and I said x is equal to 1, well, you got 1 squared plus 2 times 1 plus 4. You just follow PEMDAS. So you do your exponents first. 1 squared is 1. And then now we're going to multiply 2 and 1 to get 2. Then we bring down the 4. 1 plus 2 is 3. 3 plus 4 is 7. For the work, this is the numbers that we're going to use unless directed otherwise. -2, 1, 0, 1, and 2. Because this right here, it's going to give us our vertex. This is going to give us 2 numbers below the vertex, 2 answers, 2 outputs, and this here give us 2 numbers above the vertex. And they're going to be equal distance of your axis of symmetry. This is going to be easy to plot. So to find the vertex, you could use this formula, and that's for more advanced stuff, but I went ahead and included it. X is equal to negative b over 2a. I know some people love mathematics so much they can't wait for the next course. So if that's you, just something for you to play around with. So first thing is, once you make your table, you want to plot your vertex. Your vertex for this course is always your middle value. Your middle value. And then you plot the ordered pairs from the table and draw a smooth U-shaped line. Okay, we're looking at y is equal to x squared. It's our parent quadratic function. In this course, we're giving you all the ranges or the x values. In more advanced courses, you have to come up with these on your own. And there's a formula to figure out the vertex. But for this course, the vertex is always going to be what's ever in the middle. So this right here, it's your vertex. And this is a function, so we got our inputs. And just like with linear, we put our value for the input in for x. So it's going to be negative 2 squared. Whatever number that is, that's going to go here. It's going to go here. If you're using a calculator, make sure you put your parentheses around your negative 2, because with the calculator, negative 2 squared written with parentheses gives you 4. Negative 2 squared without parentheses gives you negative 4, or sometimes it gives you 4 depending on the calculator that you're using. You have to read the owner's manual to figure out how they want you to do it. But if you always put parentheses, no matter the operating system, you'll always get a positive number, the correct answer. Go ahead and fill out the table. I'll meet you on the next slide with my answers. Here's what I came up with. I got 4, 1, 0, 1, 4. Just recap, negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1, and 2 times 2 is 4. And just like with the linear functions, we're going to plot our relations or the ordered pairs, and then we'll connect the dots. So I'm going to go to negative 2, 4. Put a dot, so you know that's negative 2, 4. Now put a dot at negative 1, 1. Put a dot at 0. Put a dot at 1, 1, and a dot at 2, 4. And then you want to connect the dot. Remember, a parabola is a curved line, so you want to sort of curve this the best you can. And I'll let you pause the video and get some work done on your own, and I'll see you on the next slide. And this is what your graph should look like when what your graph should be, a nice smooth line. Now your solution, or your roots, or your zeros, is where your graph touches or crosses the x-axis. So notice this touches right here at 0, 0. So your solution, there's a couple of ways to write it. You could write it in what's called your solution set as 0, or you could write it as the ordered pair 0, 0. Either way is right. In this course, I primarily will use the solution set, but sometimes I'll do 0, 0. If I do that, just know they both mean the same thing, and that the solution to this quadratic is 0. Now we've got the inverse parent function, and remember, inverse in algebra and math just means opposite. So you could look at the table from the previous slide and write down all the opposites of the outputs, and you'd get the right answer. There's no number crunching in that, so it's not as much fun. But negative or inverse, inverse just means opposite. So we're going to do the same thing, but our graph is going to be opposite of what we had before, and by that I mean it's going to be a reflection over the x-axis. So you've got your negative x squared, which is really negative 1 times x squared if you're plug in your numbers in a calculator, you want to do -1 times -2, close your parentheses squared, because that's going to give you the right answer. That'll give you, because what your calculator is going to do, and it's a little calculator brain, is going to do -2 squared, which is 4. So that's PEMDAS, that's your innermost grouping symbol. Then it's going to do -1 times 4, and it's going to give you -4. So you want to do the same thing for all your other numbers. I'll set them up here, but I'll let you do the number crunching, and I'll show you the right answers on the next slide. And I know I keep saying this, but I wouldn't use a calculator because these problems are fairly basic. And the better you get by doing simple multiplication like this without a calculator, the more of a mathematical genius you're going to become. So look at what we've set up here. Think about what numbers are going to go in the table, and then plot your points, figure out where they're going to go. In just a second, I'll show you what you should have came up with. And here's my answers. I got -4, -1, 0, -1, and -4. Keep in mind, -x squared is the same thing as -1 because we've got a coefficient of -1. So anytime you don't see a number in front of a variable, it's understood to be 1. And then we're multiplying it by x squared. So -1 times 2 squared is same, -2 times -2 is a +4. -1 times +4 is a -4. Next one, you have -1 times -1 squared, which is -1 times -1 or 1. -1 times -1 is -1. 0 squared, well, that's 0. 0 times -1 is, of course, 0. Finally, you have -1 times 1 squared. 1 squared is 1. -1 times -1 is a -1. 2 squared is 4. 4 times -1 is -4. Our solutions of a quadratic is where the graph touches or crosses the x-axis. And in some cases, it may not touch or cross it, and in those examples, there's no solution. This one, it touches at one spot, which is 0, 0. So you can write it as 0 in your solution set or as an ordered pair. So this has a same solution as the previous one. Now we've got the parent function. We've got the parent function of x squared plus 1. What do you think this is going to do to our outputs and the shape of the graph? Remember, the parent function was a parabola, U-shaped graph, touched at the origin. What's this plus 1 going to do? Just pause, think about it, reflect, and then we'll see what happens. But just like before, we're going to plug these numbers, our inputs, to our function. So you'd have -2. Always put your -2 inside the parentheses. Squared plus 1. Whatever that answer is, it goes here. Next one, you would have -1 squared plus 1. That goes here. Here you have 0 squared plus 1. 1 squared plus 1. 2 squared plus 1. Then you plot your points. You connect the dots, and I'll give you a moment to work on that on your own, and when you come back, I'll have the answers for you. Well, you should have time to figure out the answers. But this plus 1, all this did is it moved or transformed our parabola up 1 unit. Remember, the parent function was down here, right, at the origin. But this plus 1 changed our y-intercept from 0 to 1. So as a result, all of our outputs here are 1 more than what we had on the parent function. So if you went -2 squared plus 1, you got 4 plus 1, which is 5. If you did -1 squared plus 1, you got 1 plus 1, which is 2. If you did 0 squared plus 1, you got 1. Then over here, if you did 1 squared plus 1, you got 2. Then 2 squared plus 1, 2 squared is 4, 4 plus 1 is 5. And then these dots, all these points are on the parabola. Here's your vertex. Vertex is 0, 1. Once again, your x-axis is your axis of symmetry. So your point at negative 1, 2, if you folded it over, it would lay on top of point 1, 2. Same thing about every other point. So if you have point 1, 5, or I'm sorry, 2, 5 and negative 2, 5, they're equal distance, right? They're 1, 2 spots from your x-axis. So 1, 2, your x-axis, 1, 2. So that's, once again, it's your axis of symmetry. Does this cross or touch the y-axis? No. So there's no solution. So for this course, if you just write n/s, no solution. Different teachers like different things. I like to be efficient, so n/s always works for me. If you ever have another math class, teacher says do something different, do it. Okay, so now we've got a more complicated looking quadratic, but it's really not. We're just going to take it one step at a time. So what I like to do is I'll go ahead and write my quadratic function, and instead of x's, I rewrite it with parentheses. Now I want to look at my input, which is negative 3. I'm going to write negative 3 in each of my parentheses. I'm going to go back and double check. Yeah, it's a negative sign. I've got my negative sign here. I got my negative sign here. Most people, when they make a mistake with this, they forget to write down that negative sign, and they get to the end, the problem's wrong, and they get frustrated, which is why I like to check my negative signs at this point. So now we got negative 3 squared, which is negative 3 times negative 3. And then we've got 2 times negative 3, which is negative 6 plus 1. Let's go back here to the beginning. We got negative 3 times negative 3, which is a positive 9. Here we're adding a negative 6. I know that when you add a negative number, it's the same thing as subtracting. So I'm going to write down minus 6 plus 1. So now we're going to do 9 minus 6, which is 3. Then we're going to do 3 plus 1, which is 4. They're all going to work the same, so just take your time, set it up properly. So it's again for the negative 2, I'm going to do my parentheses plus 2, another set of parentheses, plus 1. I'm going to come over here, I'm going to circle negative 2. When I circle that negative 2, it reminds me to write down negative 2, negative 2. I'm coming back, I'm double checking that negative, looking at it. I'm coming over here, looking at it, and it's negative 2, negative 2. Well, negative 2 times negative 2 is 4. A positive times a negative is a negative, so I'm going to write down my negative sign. 2 times 2 is 4. And then I hadn't done anything with the plus 1. 4 minus 4 is 0. 0 plus 1 is just 1. And then I'll give you some time to work the other 3 on your own. In just a moment, I'll give you the answers to the last 3 here. Okay, I came up with 0, 1, and 4. All I did was kept doing what I did on the previous slide by rewriting my quadratic function with parentheses, placeholders for my inputs. So for first one, I had negative 1. Well, negative 1 squared is 1. 2 times negative 1 is negative 2. And see, 2 minus 1 is a negative 1. Negative 1 plus 1 is 0. Once again, I did the same thing for my input of 0. Rewrote my quadratic with parentheses for placeholders. Plugged in a 0. Anything times 0 is 0, so 0 squared is 0. 2 times 0 is 0. 0 plus 1 is 1, because nothing plus nothing is 1. And I finally did the same thing with 1, so I had 1 squared plus 2 times 1 plus 1. 1 squared is 1. 2 times 1 is 2. 1 plus 1 is 1. 1 plus 2 is 3. 3 plus 1 is 4. Looking at my graph, it touches. Remember, the graph of a quadratic where it touches or crosses the y-axis is our solution. So this touches at 0, 1, so our solution is -1. And we have a new axis of symmetry. Just point that out. It's right here where x is equal to 1. So all of these points on either side of your axis of symmetry, they're equidistant from the axis of symmetry, just like it was earlier when the axis of symmetry was the x-axis. So just a fun little thing to notice. Now we've got one more that we'll look at. Some of your work, you'll have a that's other than 1. Remember, we got ax squared plus bx plus c. And we worked with some negative x squareds, and that was understood to be a -1. But let's go ahead and practice one with a -2, a coefficient other than 1. The rules stay the same. So we're going to do -2 for my parentheses placeholders plus 8. And then what's in the parentheses, we're going to square it. So we have -2. So we just do -2 times -2 times -2 plus 8. -2 times -2 is a +4. -2 times +4 is -8. I hadn't touched this, I'm going to bring it down. -8 plus 8 is 0. So you see the rules stay the same with functions. Whatever we get for the input, remember these are inputs. We just put our numbers, we substitute our inputs into the equation for the variable, and then we just work it. So take the same format, -2, parentheses for placeholders, squared plus 8, put -1 in it, and do the same thing with 0, do the same thing for 1, and do the same thing for 2. Work all of these problems. Pause the video while you do it. You don't want to cheat yourself of the learning. And in a second, I'll show you my answers. So I came up with 6, 8, 6, and 0. So once again, we did -2. We had -1 squared plus 8. So -2 times 1 squared is 1. So -2 times 1 is -2. -2 plus 8 is 6. Then we had -2 times 0 squared plus 8. Well, anything times 0 is 0, so we had 0 plus 8. So that checks out. Then we had -2 times 1 squared. 1 squared is 1. Then we had -2 times 1, which gave us -2. -2 plus 8 gave us 6. And lastly, we did -2 times 2 squared. 2 squared is 4. -2 times 4 is -8. -8 plus 8 is 0. So that's how I got the tables. Your graph, your solutions with the graph is where it touches or crosses, right? So touches or crosses is the solution. If it doesn't touch or cross, there's no solution. So here our solution is -2, 2. You could write it as -2, 0, 2, 0. Here's one reason I like the solution set. Here we wrote 2 numbers and some curly things. Here we wrote 4 numbers, so it's just a little bit easier. And that's how you find the solutions of a quadratic by graphing. If you're lucky, you're given the graph, and you just look to see if it touches or crosses the x-axis. If it doesn't, there's no solution, no work to be done. If you're just given a quadratic and you're expected to graph it, well, you figure out some ordered pairs by plugging your inputs into your function. then you figure out what your outputs are, or ordered pairs. You plot your ordered pairs, and then you draw your graph. In this course, your middle, whatever in the middle in this course, is going to be your vertex. And that's just for this course. In more advanced courses, you'll have to use some mathematics to figure out the vertex. So that's outside the scope of this course. But that will get you started on the work. And to recap, our x-intercepts always the solution. If there's no x-intercept, there's no solution. The y is always the constant. And then use a table to create points. And we'll give you the points to plug in the table in this course. And just remember, you always, when you're graphing, you start with the vertex, which would be the middle number of the table. So the middle number of our table is going to be the vertex. And then you can always use opposite points. By opposite points, here's your axis of symmetry. It looks like here, axis of symmetry is 2. So if you had, see this point here, that's 0, 0. So we're 1, 2 steps away from the vertex, so we put our next dot at 1, 2. If we were here, it looks, we went over 1, 2, 3. We would put our next dot at 1, 2, 3. So that's what we mean by opposite points. You find a lightest point, you walk over to the axis of symmetry. Ever how many steps you take, you walk over that many more steps until you're on the parabola. You plot your point. Once again, if you have any questions, let me know.